guys. So today we will discuss about the topic called write, which is an important topic in computer networks and also data management systems. So what is meant by write? Write is nothing but redundant area of independent disks or inexpensive disks. Why it is called as inexpensive? Here we call it as inexpensive. Why it is called as inexpensive? It is called as inexpensive because the company stores the customer's data in their servers. The customer's data is very precious to the company. It is nothing. The hard disk's prices are the server room's prices are nothing, but the company customer's data is very important to the company. That is why it is inexpensive disks, but expensive data. The data is very much expensive to the company, isn't it? Yes, it is expensive. So redundancy in hard disks is nothing but storing the same data in multiple disks. Storing the same data in multiple disks to prevent data loss in the event of unwanted circumstances like disk failures. Yes, in the event of disk failures, storing the same data in multiple disks is nothing but redundancy. Yes, we have different levels in redundancy. Level 0, level 1, level 5, level 6 and level 10. We will discuss in detail about these levels. What is level 0? In level 0, see, take as example A, B, C, D. We have data A, B, C, D. So, in write level 0, the data is distributed, but it is correct. The data is correct. A, B, C, D. This is hard disk 2 and this is hard disk 1. Okay guys? So this is hard disk 1 and this is hard disk 2. Yes. The data is spread A, B, C, D. It has best performance among all these because the read and write operations are very much fast in this level 0. Yes, but it is not fault tolerance. If in the event of disk failures, like assume it as the hard disk 2 is failed, then the total data will be lost. Then it is not fault tolerant. Then you will understand it is not fault tolerant. But it can give better performance. But what is the use? It didn't give us the fault tolerance. So no use of fault tolerance in level 0. We don't have fault tolerance in level 0. We will now move forward to the level 1. What is level 1? Level 1 is nothing but the data is duplexed or copied, mirrored. Then see here, the same data is copied into the same another hard disks also. See, the ABCD data is write 1. The ABCD data is copied, the same data is copied into the second disk also. We should have, for level we should have definitely 2 devices, 2 hard disks. Sorry. We should have 2 hard disks in level 1 guys. So, the same data is copied. Here the fault tolerance is there. Yes, the fault tolerance is there. Because if in the event of disk failures, assume it as the hard disk 2 is failed or it is gone. Then we have the same data in hard disk 1. Then the customer's data is not at all lost. We have in level 1. So it has fault tolerance in level 1. In level 1 we have fault tolerance. It has better performance too. Better read performance too. Yes. In level 1 we have better read performance. So this is all about level 1. We will now discuss about level 5. What Verifier runs on parity bits. What is meant by parity bits? See, in the event of disk failures, if any disk failures, assume it as this is hard disk 1 and this is hard disk 2. See, assume it as hard disk 1 and hard disk 2 and hard disk 3. In the event of disk failures, assume it as hard disk 3 is failed. Then, basing on this parity, the other two, basing on these parities, this disk can be recovered easily. The parity concept uses XOR gate. Do you all know what is XOR gate? See here. XOR gate. See, X, Y, and it is XOR. XOR function. If both the bits are same, then it is 0. If one of the bit is 1 and another bit is 0, then it is 1. If it is 0, it is 1, and the same will be continued to, and it gives 1. Okay guys? So assume it as A as 0 and B as 1. Okay, what is the parity bit? See here, the C bit is 0 and the D bit is 1. Then we lost D data. Here we have XOR function. XOR function is equal to, see, assume it as 0 and the XOR function is 1. See, 0, 1. We have these two. We have these two. And what is this? This. Automatically it can be recorded as 1. So the XOR function is used here in parity, the concept. And also important point to notice, the parity is shared among all disks. Parity is shared among all disks. If any event failure, if there is some event failure, the other disk can be helped to recover the lost disk. So this is about level 5. It can withstand it can withstand. That means it can withstand one hard disk failure. If one hard disk is failed, then we can recover easily in level 5. Then we must and should have 3 bits then. 3 bits case. 3 hard disks. What do we need? 3 hard disks in level 5. We must and should need 3 hard disks. Maximum it can go up to 16 in level 5. Okay? So this is all about level 5. It can withstand only one hard disk. And the disadvantage is it can't withstand up to 2 hard disk failures. If any unwanted circumstances exist, 2 hard disks are failed, then how it can be recovered? Here the picture constant speed is level 6. It can withstand 2 hard disk failures. Very fault tolerant. The level 6 is very much fault tolerant. See, A, B, C, D, take data. We are giving it to write 6. It uses the technique called double parity. It stores double parity bits. A, B, and it uses parity 1. A, B, B, parity 1, and A, B, parity 2. C, D, parity 1, C, D, parity 2, D. Like that it uses double parity bit. E, F, parity 1, E, F, parity 2. Like that it uses double parity guys. It uses double parity. That means if takes days. In among these days, if the hard disk is failed, if the other hard disk is failed, then what happens? That the other data will be lost. We won't take risk now, guys. So the double parity bit here came onto the screen, and it says it and it will withstand 2 hard disk failures. Yes, it is most performant, and we will now discuss about what is level 10. It is nothing but comparing of scripting level 1 and level 0. Scripting and duplicating. See here. Okay. Now, see. We have A, B, C, D, E, F data. Then in RAID 10, it is duplicating and it is spreading to C, D, D. It is spreading and duplicating. Have you understood? Here we will have performance and best for tolerance too. In level 10, we have best performance. We have discussed it has level 0 has best performance, but not for tolerant. But in level 1, it doesn't give performance in writing operations. If we are editing in level 5 or level 6, it is somewhat slow because it has to calculate parity bits. So the writing operations are that we are if we edit any data in hard disk, then it can be slow because it has to calculate the parity bits among what we have edited. So in level 0, it gives best performance and fault tolerance. We have these two in level 0. So thank you guys. Thank you for watching my video on RAID. Happy learning guys. Thank you.